OBD2 Explained, a simple intro. OBD2 is a core topic in automotive data logging, from car diagnostics to vehicle fleet optimization. Yet you may be asking, why another article on OBD2? Despite the importance, we find that most OBD2 intros are too high level, technical, or lack the practical data logging angle. Since visitors loved our intro to CAN bus, we again asked our non-engineer to write a simple intro, this time on OBD2. Below, we cover the basics of OBD2, the relation to CAN, how to log OBD2 data, and the OBD2 parameter IDs, PIDs. Enjoy! What is OBD2? Onboard Diagnostic, OBD, is your vehicle's built-in self-diagnostic system. This is how you've probably experienced OBD in practice. Ever notice that malfunction indicator light pop up on your dashboard? That's your car telling you there's an issue and you should visit a mechanic. Your mechanic then uses an OBD2 scanner to connect to the OBD2 16-pin connector under your driver's wheel. With this, he is able to read out the diagnostic trouble codes, DTCs, and understand the issue without taking your car apart. So, where does OBD come from? The system originates from California, where the California Air Resources Board, CARB, started requiring OBD in all new cars in 1991 for emission control purposes. By 1994, the CARB made the OBD2 standard mandatory in cars sold in 1996 plus. The OBD2 standard was recommended by the Society of Automotive Engineers, SAE, and secured a standardization of diagnostic codes and the OBD connector across manufacturers as per SAE J1962. From there, the OBD2 standard was made mandatory across USA for cars and light trucks sold from 1996 and in the EU from 2001 for gasoline cars and 2004 for diesel cars, including medium-duty vehicles since 2005 and heavy-duty vehicles since 2010. Today, the OBD2 system is thus standard in most vehicles. It is imperative in facilitating easy error resolution, and the standardization of DTCs prevents car manufacturers from locking in the car owners with proprietary diagnostic tools. So, what's the difference between OBD2 and CAN? For those of you confused, OBD2 is a higher level protocol. Think of it as a language, while CAN bus is a method for communication, like a telephone. In fact, the OBD2 system can use 5 different bus systems, or signaling protocols, for communication. Since 2008, CAN bus ISO 15765 has been made the mandatory protocol for OBD2 in all cars sold in the US and is today the standard in cars and light vehicles. And why should I care about OBD2? If you're here, you want data. Mechanics obviously care about the diagnostic trouble codes. Maybe you do too, while regulatory entities care about the emission data. But OBD2 actually includes a fairly broad range of standardized parameter IDs, PIDs, that can be extracted across most regular automotives. This means that you can, in example, get human-readable live OBD2 data from your car on some key parameters, which is pretty cool. A lot of this data is also available outside the OBD2 protocol, but these CAN messages are typically proprietary. This means that you would need to decode them via a database of conversion rules/parameters, which is not always available. As such, for example, car hobbyists accessing such data would require reverse engineering, CAN sniffing, or hacking. In other words, the OBD2 standard is often the most convenient way to access basic data parameters from your vehicle. Wikipedia has an excellent article on the standardized OBD2 PIDs. We also offer an OBD2 online converter tool where you can enter a message to return the PID info and converted data. Check it out. How does OBD2 data logging work? In practical terms, OBD2 works as follows. You can connect an OBD2 scanner or OBD2 data logger to the OBD2 16-pin connector. Via the tool, you enter request messages, queries, transmitted via the CAN bus. The relevant ECUs react and send response messages via the CAN bus. Why is this important to understand? It means that you will not see OBD2 data if you plug in a passive, silent CAN logger or interface to your car, though you'd see plenty of raw CAN frames. To log OBD2 response messages, your OBD2 data logger needs to be able to send the request messages. This feature was recently added to the CAN logger X000. Can you please explain OBD2 PIDs for dummies? If you want to get started with recording data from your car's OBD2 system, it's helpful to understand the basics of the message structure. Don't worry, this will be kept high level. In simplified terms, an OBD2 message is comprised of an identifier and data. Further, the data is split in mode, PID and data bytes, AH, BH, CH, DH. An example of the request or response CAN message for the PID vehicle speed with a value of 50 km per hour can look like this. Request 7DF 0201 0D. Response 7E8 03 41 0D 32. You can try to enter the response message in our OBD2 message converter to confirm the result. Below, the various parts for the OBD2 message are explained. Identifier. For OBD2 messages, the identifier is standard 11-bit and used to distinguish between request messages, ID 7DF, and response messages, ID 7E8 to 7EF. Note that 7E8 will typically be where the main engine or ECU responds at. Length. This simply reflects the length and number of bytes of the remaining data, 03 to 06. For the vehicle speed example, it is 02 for the request, since only 01 and 0D follow. While for the response, it is 03 as both 41, 0D, and 32 follow. Mode. For request, this will be between 01 and 0A. For responses, the 0 is replaced by 4, in example, 41, 42, 4A. There are 10 modes as described in the SAE J1979 OBD2 standard. Mode 1 shows current data and is an example used for looking at real-time vehicle speed, RPM, etc. Other modes are used to, in example, show or clear stored diagnostic trouble codes and show freeze frame data. PID. For each mode, a list of standard PIDs exist. In example, 0D for vehicle speed. For the full list, check out the aforementioned Wikipedia OBD2 PID overview. Each PID has a description, and some have a specified minimum, maximum, and conversion formula. The formula for speed is, in example, simply A, meaning that the AH data byte, which is in the hex, is converted to decimal to get the kilometers per hour converted value. For RPM, PIDOC, the formula is 256 times A plus B divided by 4. AH, BH, CH, DH. These are the data bytes in hex, which need to be converted to decimal form before they are used in the PID formula calculations. Note that the last data byte, after DH, is not used. Importantly, not all cars support all PIDs, in particular older cars. As such, you may find it far easier to get valid OBD2 data returned in a car from 2015 versus a car from 2007. Yes, we tried. I want to get started. What OBD2 recorder do I need? For the casual hobbyist and the more advanced CAN sniffers / CAN hackers, OBD2 can be a helpful source of interesting data. For the same reason, you will find many tools that give you access to the data in different ways. OBD2 scanners / code readers. Used mainly in static reading or clearing of diagnostic trouble codes. They are, an example, used by mechanics to look up the underlying issue behind a malfunction indicator lamp, MIL. OBD2 scanners vary by the degree of code coverage and features. OBD2 data loggers. Used to log OBD2 data from a car over time onto, an example, an SD card. This can be helpful for post-analysis and to, an example, analyze patterns, correlations, etc. Further, for diagnostic or